The Yamnuska bike helmet bolter sent me his quick draw so we can actually test the real quick draw that we talked about in previous videos. And we're going to give you an update on some lab upgrades I did and talk about projects we've got coming up. This probably won't be that quick of a Monday video. Stay tuned. I'm Ryan Jinks, and I'd like to give you guys an update video. I'll try to do it once a week, and this is filmed just Sunday, the day before I release this tomorrow. And I want to tell you about this because this is pretty cool. We'll start with this. The Yamnuska Boulder, who signs it the bike helmet bolter, he basically reached out to me and sent me this. And we talked about context, because the article was like, oh, noob alert, right? And that's the video we made. Super interesting what he wrote me on context. He is new. He did make mistakes, but the context makes a lot more sense. I'll give you the highlights here. He didn't know it was against the ethics to bolt tread routes. I have learned my lesson. The bolt in the picture that Grip magazine published, the one that was like sticking way out, was way out of gravity and embedded in the rock by at least 2.5 or 3 inches. The reason why it was sticking out was because we were retreating and wanted the bolt to be out of the way for future climbers. We placed it up high and off to the side. They were using 5.5-inch expansion bolts and stainless steel to protect against galvanic corrosion. Awesome. So he put thought into it. He put it out of the way, and just because it was sticking out a lot doesn't mean it wasn't in the rock enough. Because I mean, if it was 3 inches in the rock, it'd probably be okay. A pack of 6 black diamond quick draws, the summary is expensive. This is literally 50% of the price and about maybe 50% as strong. We'll find out. But the context is super interesting because they used these draws to retreat the overhanging wall with, and they used the black diamond quick draws to climb with. That is pretty clever. They read in the Advanced Rock Climbing book by Topher Donahue to not be afraid to leave gear on the side of the mountain if you need to retreat from a climb. So it is nice to know this wasn't exactly for a life-supporting situation, but we're going to test it anyways. This is a 12 kilonewton carabiner off of Amazon. Not for climbing use. And this battle cord rope has a tensile strength of 2,650 pounds. Hardware store rope. Let's go break this, and I'll give you the tour of the lab while we do it. We're building a drop tower, 45 feet tall. It's gonna look something like this. Not quite exactly. We got all the footings done. This was a lot of work. This is about a yard of concrete in each one of these 36-inch holes, pretty deep. And of course, I had to have some fun and embed some gear in there. Then these 3 holes line up with these three holes, and then sits on here and bolts that to the bottom of this. The other leg's over there. We're going to start building the base, and yeah, just keep building. Power washed all of this. That took a while. Kind of got the dirt wet. It was just a mess, and got the crane working. We put a whole new cable on there. Got rid of all the concrete here and took that to the dump. Brand new, well, not brand new cable, brand new swedge. And, but the cable's in great shape. Learned a lot about cranes. But anyways, this is going to be the front side, and things are going to go from here, and they'll swing out when we do swing tests. Now I'm thinking about putting some shredded black tire, deeper right there than it would be on the sides, and it kind of would slope in with a drain. Lots of groundwork still to do, but we're going to be building it first. So we got some gussets here for supports in the corners. We got the other pieces out there, and this is our main system here. What's nice is we're going to be able to build like a platform that goes diagonal. We can stand here and work on our samples. We're going to cut out the middle, so when samples want to swing through, they can. Thinking about putting a bolt here. I want to test anchors, but at the end of the day, I just want to connect my load cell to this and hang for most things that I just I'm not trying to test the anchor. We'll be testing sliding X's versus quad anchors and all this stuff, and we'll drop test things on them. But this goes up and over, and it's going to be on a trolley, and then we can move our sample away or right next to this to fall direct. I don't really want a metal sled like a lot of drop towers. That's not very realistic, and this will give us lots of opportunities to do cool stuff. So I've spent a lot of time organizing. What's nice is I've cleared off my tables. This is the projects in progress. We've got some BL escapers. We've got some old bolts to test. And we have some pitons and rings we're gonna test how strong these are. 4mm Kevlar and Technora 12 braid, super clever. Some cams and stuff. This is our 81-to-1. But what's neat is this rack allows me to, be a lot more organized. And didn't quite know where to put all this. Then all my stuff over here is all labeled fresh and organized. Feels good. In about 3 weeks, I'm gonna decorate this, and then I'll have a dual studio look. So it's you'll see like how nice it is to have the screen jump around. And we officially have our 2 load cells and systems. This is for the LabJack, and this is for Lodestar. And this is to keep the recoil from basically hurting them. I'm trying to be nice to them. The cables that come out of the side shouldn't get damaged in any way. And there's no screen on the front to hurt. So hopefully. And then once this is confirmed like it's super, super good and reliable, I'll probably eliminate this and move this over. But this is exciting. But so is this. This is a wall. This keeps me safe. So when I stand here and work on the computers, then I can push the button from here, and basically I'm safe behind the wall. There we go. All right, LabJack is connected. I just enter this. Yetze has helped me with the software of that, so that's nice. Now this is my Lodestar system, and we've got some spikes happening. This is the sample I did as a test, but the spikes say I got 51 kilonewtons. I was brake testing like paracord. So I got to figure out what's causing my electricity, and this guy's doing it too. You can see here, if I open up text document, that it changes on its own. Okay, so recognizes the board, software is opening up, and the problem is we're getting the spikes in voltage readings. Basically, electricity goes over to these glorified resistors, and it reads the difference of the electricity coming back, and that's how it tells what force things are. And I don't know if it is, we're going to check to make sure the electricity is clean. We're going to make sure that the power strip it's connected to is not interfering. We're going to find out if this table is interfering with the cables or if these units being near each other. But this is the battery powered one, and it's giving me the same problems. As you can see, I haven't even pulled anything, and it's giving me that reading. Now that was only probably one quick spike. If you look at the CSV file later, and if I reset it, it would be fresh. But it does save the CSV files, and I can check it out later and eliminate that one spike and actually put it in a chart. But yeah, something to solve. So I have it at 20 seconds. Let's go down to 15 at 1,000 hertz. I'll push 0, push start. Now I don't get a live reading with this system because it's meant to be super fast, and I can go up to 10,000 hertz, which allows us to do a lot of interesting things on the drop tower to find out how fast you need your load cells. And boom. Now this part's perfect. It's basically 0.01 to negative 0.01, but these spikes are sometimes pretty big. Now we only got a 0.09 spike, but the other day I got like 17 kilonewtons. So we're going to test this sample. We're gonna turn both of these on, and we're also gonna turn on this guy, which I know is still accurate. I test it with my other load cells regularly. And so we'll have 3 dynamometers to test this 12 kilonewton carabiner and cable. Open that one up, 0. And we're gonna click start, just so you can see the process. I've got 15 seconds. There's that. Haha, sick. It actually worked this time. Oh, yesterday was hard. 5.37. And up here, 7.43, but I think it started at 2. So, super good enough for not that important of a sample. And about 1,200 pounds of force, which is interesting and predictable because this is 2,650 pounds of tensile strength. Well, when you put things in a knot, it reduces it 50%. Now, at only 5-ish kilonewtons and a whipper can generate 6-ish, I personally would not be whipping on these, but they were only meant to keep them close to the wall while they were rappelling. They were not even rappelling on them. So, now let's test the carabiners. All right, so we got 12, and this is calibrated, so without any weird spikes, this is being accurate. And that one was about 2 kilonewtons off again, and 2,300 pounds of force. So, about 12 kilonewtons. Not made for climbing, by the way. So I just broke the second one and forgot to push enter properly, so that didn't turn on, and I forgot to film it. But we got 2,950 pounds of force on that one. However, we got 43 kilonewtons. That's not how this works. You can see here, again, we got about 14 in this range. But this sample actually gave us what I call a dirty chart. So these spikes is caused, it obviously wasn't last time, but it is this time, so it's a super big mystery. I wish that was running so I could show that that was probably doing the same thing, which even if I pushed it now, then it would show that it's still moving even with no sample in there. So I have no idea. What do you guys think this is? Because they're 2 different power sources, 2 different softwares, 2 different load cells, and the only common denominator is that they're both here. Interference, I don't know, like there's nothing out here. There's no microwaves, I don't know. So I really like the fact that we've got 2 softwares, 2 computers, 2 load cells, and even these all-in-ones I'm gonna probably keep embedded in the system for a while. But the drop tower, once we get this all dialed, this is gonna be a really nice system for the drop tower to identify exactly how fast we need our load cells. Right now, the programming for the LabJack one is at 200 hertz, but that one can go up to like 10,000 hertz as well. I don't think you need more than 2,500 even for wires or super static things like, let's say, Dyneema slings. And climbing ropes, I don't even think you need 100 because it's so dynamic and the peak force is so slow. We'll cover forces later. So something really cool about basically our load cell system is Luca Mustafa nominated us for the Shuttleworth Foundation's Flash Grant program. And it was kind of like, he told me it was coming possibly, but it kind of came like, oh, you just won an African inheritance from Prince whatever kind of email that looks like spam. Oh, you just won whatever. But no, I got a grant. So $5,000 from the Shuttleworth Foundation. And that basically is covering all of the scientific equipment that we're doing, the upgrades, the software, the whatever, and that's super essential for the drop tower. I literally could not do the drop tower without these faster load cells. LabJack also donated 2 T7 Pros, and Yetza's helping me do the software with it, and Marcus Bird helped me put it together because LabJack is basically hardware, and the software is usually custom designed because it's super flexible. Everybody has different needs for this kind of stuff. Lots of people helping me doing a lot of different stuff and a lot of support from people, plus a grant on top of it. So this has really, really helped us not use up the money that you guys have donated for the drop tower. So I think my budget right now is around 10 grand for the drop tower. I used Larry's backhoe. Larry's been helping a ton. I'm gonna pay him for his time, but he's got a lot more mental energy and emotional energy into this project than I could ever really pay him for. I'm working as hard as I can on this myself to keep the costs down. The rubber tires might cost a few extra dollars than like gravel, but I really don't want gravel out there. Anyways, trying not to get too mushy on you. I love the support I've got. I have a really cool lab, and once this drop tower is up with a nice foundation, decorated decals, space nets on it, maybe a climbing wall on the back, and a little watch tower thing at the top so you can like see as far, you know, whatever. Pretty rad. Speaking of awesome, tomorrow, the day you're gonna see this video, is I'm going to Washington State to go canyoneering with Brent Roth, and we're going to do as many videos as we can in basically 5 days on how not to canyoneer. We're going to take some load cells with us, measure the forces on certain rappels, diagonal stuff, maybe Tyrol stuff, maybe rescue edge. We'll do as much as we can. But I'm trying to introduce other sports into this. We have a skydive, how not to skydive series coming up. We broke test a soft link as our first episode, and we plan on doing more. We of course have more caving videos coming out. Of course, more climbing videos coming out. How not to cook on El Capitan is almost done being edited. The MBS, or minimum breaking strength of gear ratings, is a myth. Don't hate me for the title. You'll see the video. That's coming out soon. We tested tri-cams and nuts in real rock. Those videos I think are done being edited. And what else do I got coming out? Oh yeah, Sweden's episodes and Doug Ross's interviews and other brake tests we've done that I haven't released yet. And anyways, we've got a lot more we're planning on doing. So really appreciate you guys subscribing and liking these videos. I am trying to get to 100,000 subscribers by the end of this year. It's an arbitrary number, but come on, it doesn't cost you anything. The last topic for the day is how not to tie a rope. Our new series I'm thinking about doing. With the drop tower, we're gonna find out if knots break exactly the same if you drop something heavy enough to break them, which I'm gonna have to have a pretty heavy sample. But if they don't, we'll slow pull test them, because some ropes are slow pulled and some ropes are, you know, you take a fall on and you want to know how strong they are. They're strong enough to hold you, but we kind of want to know the limits of the knots. They do reduce the strength. Some knots preserve more strength of ropes. And I'm thinking about brake testing a lot of knots. So you guys have been requesting bowlines for a while. Well, let's just take the figure 8. I could show in the video one knot. Let's just say one variation of a figure 8 on a bite. How to tie it in the video. Super short videos, minimal talking, tightly edited. Then we could pull it to 4 kilonewtons or drop an 80 kilogram person, just a factor 1, to see how hard it is to untie. And then we could do like 3 samples in the slow pull machine and 3 samples on the drop tower. Or I could test 11 millimeter, 9 millimeter, and 7 millimeter ropes and maybe a stretchy and static webbing. And all these tests can go bam, 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 and just give you the number. Like, I wouldn't torture you for 20 minutes with like 12 tests, but like 12 to 20 tests per knot is a lot of work. I want to know if that's worth it to you guys, if there's value in that, and what kind of format you want to see that in. And then the titles could be the names of the knots, like how not to would be with a K, would be the title. Figure 8, how not to bull in on a bite, how not to follow with a follow through, whatever, like Zeppelin knot, XYZ, and just like actually do like 100 knots over several years while we have this lab. Not only would you learn how to tie it, how hard it would be to untie it, but how it looks as you pull it, how it reacts when you do different things. I think there'd be a lot of value to it. I just don't want to go through that much work without getting your guys' feedback on how to do it. I'm going to try to have feedback come through either in the comments below here on YouTube or on my Discord page that I'm working on building. So if I can get that up today, I'll put that link in the description below to get your feedback on why I have bad electricity going into my system, and what we can do about how not to in the formats that we do that. Now, I did try to hit up Mammut, and I'm trying to get a spool of the different diameter ropes. Technora sheath with Dyneema core, I want to know if how it performs with knots. Because you're not supposed to tie knots in Dyneema, but all of a sudden you put a Technora sheath on there and it's okay? So they basically told me no. So now I'm going to hit up Sterling, and I'm going to hit up Edelrid, I'm going to hit up everybody I can in order to see if we can get some ropes donated for that project. If you have any contacts with any rope manufacturers that are name brand ideally, hit me up, because it'd be nice to have a rope manufacturer help support this. I really appreciate your guys' donations. I had a few $10 and $20 things come in the last few days. I had a $200 thing come in the other night. Super rad. I can't send thank you notes to everybody. My emails kind of get blown up. Please don't email me ideas. I'm going to try to put the Discord and read the comments. Unless you have like your super electrical engineer and you know exactly what my problem is, then Ryan@slackline.com. But I'm trying not to have my emails blown up. I still respond to everybody. It's killing me. So be gentle. But I do love engaging with you guys. This is all super fun, and I'm going to have fun canyoneering this week. And I'm pretty excited about the video you're going to see on Wednesday. It's a secret. Cheers.